November 2015, paper 1 combination, maximum mark 15. This problem will cover increasing and decreasing function, then your definite integration, and the last one is your equation of a tangent. So let y is equal to f of x, where x is lying between minus 0.5 to plus 6.5, including the following diagram shows the graph of f dash, the derivative of f. The graph of f dash has a local minima when x is equal to 2, local minima when x is equal to 4, and crosses x-axis at 5, 0. Local minima means what? Derivative f dash has a maximum point is 2, derivative of f dash is a minimum point is 4, and derivative of f dash is equal to 0 when x is equal to 5. Okay. When I say increasing function means what? F dash x is positive. F dash x is positive means what? This one. Here it's an increasing function. Not only it is going upward. Here also you can see increasing function, but between this to this, you can see this total graph is lying below the x-axis. So from 0 or less than 0 to up to 5, you can see the total graph is below the x-axis. So during that process, your graph is decreasing. And after 5, the graph is increasing because it is above the x-axis. Okay, because f dash x is positive above the x-axis. Now explain why the graph of f has a local minima when x is equal to 5. Minima means what? This one. And we are talking about the graph of f, not f dash. Minimum point means what? Before minimum point, the graph f is decreasing. F is decreasing means what? F dash x is less than 0. At minima, f dash x is equal to 0, and after minima, the f dash x is greater than 0, which you can see very clearly in phi. At phi, I have said crosses the x-axis, so y is 0, so f dash x is 0. Before phi, the graph is negative because it is below the x-axis. After phi, the graph is positive because it is above the x-axis. So clearly, this is the reason x is less than phi, f dash x is less than 0. At x is equal to phi, f dash x is equal to 0. And x is greater than phi, f dash x is positive, so greater than 0. So therefore, it is a local minimum. Second, find the set of values of x for which the graph f is a concave down. Now this is slightly confusing because they are talking about f is concave down. Concave down means what? Like this. That means this is the graph of f. Sorry, this is the graph of f dash. If f is concave down means what? F dash is decreasing. So right now you can see between 2 to 4, the graph is decreasing. F dash x is decreasing, not f is decreasing. F dash x is decreasing. If f is decreasing, that means this full part is decreasing. Okay, f is increasing, that means full part is increasing. But right now they are talking concave down. Right now they are talking about concave down means what? F dash x is decreasing. That means it is happening between 2 to 4, because you can see here it is decreasing. Otherwise it is increasing, it is increasing. So between 2 to 4 it's decreasing. So that is why f dash x is decreasing. So concave down between 2 is less than x is less than 4. Next one. The following diagram shows the shaded region A, B, C. The region enclosed by the graph of f dash, that means still this is a graph of f dash. The x-axis and the y-axis and the line x is equal to 6, that means this. The region of the area of the region A is 12. The area of the region is B is 6.75, and the area of the region C is also 6.75. What is happening? When the area below the x-axis, the area is negative. When the area above the x-axis and below the curve, area is positive. So you can see A and B both are negative. So although they said 12 and 6.75, while taking we will take a negative. Given that f of 0 is 14, find f of 6. Now we can see that total area is starting from 0 up to 6. But it is divided into 3 parts. 0 to 2, that is A. 2 to 5, that is B. 5 to 6, that is C. So I'm separating this. First I'm writing 0 to 6 f dash x dx. This is your this is your f dash x graph. 0 to 6 f dash x dx. First part 0 to 2 f dash x dx. Second 2 to 5 f dash x dx. And third 5 to 6 f dash x dx. Whenever you take derivative, whenever you take integration of a derivative, integration and derivative will cancel each other. Integration of f dash x would be f of x. We don't know the function and we don't know the expression, so we are just writing the integration of f dash x is f of x. Remove integration sign, write down lower limit and upper limit behind this bracket. Integration of f dash x dx we already know, that is 12. I'm writing minus 12 because it is below the x-axis. Integration of f dash x dx from t to 5, we already know b, which is 6.75. I'm below the x-axis, so minus 6.75. But integration of 5 to 6 f dash x dx above the x-axis below the curve, so it is, I'm still writing plus 6.75. Now this will get cancelled. Here we left with minus 12. Put upper limit 6, f of 6 minus lower limit 0, f of 0. F of 6 minus f of 0 is minus 12. I want to find out f of 6. Isolate f of 6, take f of 0 on the other side. F of 6 is equal to minus 2, minus 12 plus f of 0. What is f of 0? F of 0 is 14. They have given here. So minus 12 plus 14 is 2. So f of 6 is equal to 2. That means actual function f when x is equal to 6, y is equal to 2. This is the way of finding. Last part. They are introducing new function g of x. What is g of x? It's a composite function. It is basically f of x bracket square, not x square. F of x, the full bracket square. Given that f dash 6 is 16, that means at x is equal to 6, the derivative of the graph is giving you 16. That means slope at x is equal to 6 is equal to 16. Find the equation of a tangent to the graph of g at the point when x is equal to 6. Equation of a tangent is y minus y1 is equal to slope of a tangent into x minus x1. What do I know? x1? Yes, 6. What do I know? mt? Yes, I know that also. But that is f dash x. I want a g of x. So we have to convert and we have to find out each and every value. So these are not your x1 and y1. So let's first find out the derivative. G of x is equal to g dash x. When I'm taking a derivative of f of x bracket square, first I will take a bracket derivative, that is 2 will come down. F of x will remain as it is. Rest to power is decreased by 1, that is 1. And we took a derivative of bracket which contains x or f of x. We haven't taken the derivative of f of x, so we will take a derivative of f of x which is f dash x. So g dash x is equal to 2 times f of x, rest to 1 is f of x, and f of x derivative is f dash x. Now we want particularly when x is equal to 6. So I am writing x as 6, 2 as it is, f of x as 6, f dash 6. This is my slope, this is my actual slope, 2 as it is, f of 6. F of 6 we already know, which is 2. So here, f dash x they have given 16, that is here. So 2 times 2 is 4, 4 into 16 is 64. So slope at x is equal to 6 for g of x is 64. Now find out y1. x1 is equal to 6, y1 is g of 6. G of 6 means what? F of 6 full bracket square. What is f of 6? I repeat again, f of 6 is 2. So 2 square is 4. Now you got y1. You got x1, you got slope of a tangent. So y minus y1, that is 4, is equal to m, that is 64, times x minus x1, that is what? 6. Keep y as it is. 64 into x is 64x. 64 into 6 is minus 384. Plus minus 4 goes on the other side, becomes plus 4. So y is equal to 64x minus 384 plus 4 is minus 380. That is your final equation of a tangent. Thank you.